Welcome to 6.6, Solving Exponential and Logarithmic Equations. This is our first video for this section, and our essential question in 6.6 is how do you solve exponential and logarithmic equations? It's a good question. So, let's learn about it. And we're going to start with essential vocabulary. And that is, what's exponential equations? They are equations in which variable expressions occur as exponents. Okay? So that means I have something and it has a power that has a variable in it. So that leads us to our core concepts. The property of equality for exponential equations. If b is a positive real number other than 1, then b to the x equals b to the y if and only if x equals y. So if our bases are the same, it means our powers have to be, and they equal, powers have to be the same. So 3 to the x, see there's our exponential equation there, 3 to the x equals 3 to the 5th. Well, the bases are the same, therefore the powers have to be the same. Okay? So let's go to our problems here, and we're going to solve these exponential equations. Now, one of these has a base of 100, and the other has a base of 1 over 10. But I want to make them have the same base. Well, 110 have something in common, and that's the number 10. Okay? So I want to write both of these as base 10. Okay? Then my bases will be the same. But that does something. So let's just look at this 100. How can I make 10 be 100? Well, 100 is 10 squared. So 10 to the second power will equal my 100. So I'm going to write that. But I still have that x up top. So I'm going to have that 2 being times x. Okay, so I took care of this left side. Now if I take care of the right side. So first I'm going to look at 1 over 10. And I want to make it just 10. So remember, if I want a 10 to be in the numerator, but it started in the denominator, the way we move them up and down is making it negative. So it's a negative 1 power, because I still have the 10. But I have to have that times x minus 3, the power that I already had. Okay? Bases are the same, and then I have powers. Well, that property of equality for exponential equations said if my bases are equal, then their powers have to be equal. So I can write that out. 2x has to equal negative x minus 3. And I need to solve for x. So I'm going to first start by distributing this negative. You could do that, or you could divide by the negative. You got options here. But if I distribute that negative, I end up with 2x equals negative x plus 3. Okay, it's the negative times x, the negative times a negative 3. And I'm trying to solve for x. So I'm going to add x to both sides. Okay, I end up with 3x equals 3. Still need to solve for x, so I'm going to divide by 3. So that gives me my final answer of x equals 1. Okay? Let's try it with number 2. All right. Well, can I use that property? I can't make both of these have a base of 2. So what I'm going to do is use something I know from a previous section, and I can get an x out of the power by using my rule of, or my, like just the definition of logarithm. Remember, log base 2 of 7 equals x. Okay, so I can write that out. The base is still the same, log base 2. Remember, we jump over the equal sign, and that gets what's inside the log. Then it equals the power. Now I can solve this. Okay, And in the last section, I showed you how to do the change of base formula. So you could do the natural log of 7 divided by the natural log of 2, or just the common log of 7 divided by the common log of 2. But now I'm also going to show you, if you have a graphing calculator, or at least one similar to this, you go to the Math menu, and I'm going to scroll all the way to the bottom. I have something that says log base, okay? If you don't have that, you're going to have to use that change of base formula. But if you have this button, you can push it, and it lets me change the base of my log. So I'm going to put in a 2 and move inside the log and put the 7 and push enter. And that tells me that my x is approximately, and we're going to go 3 decimal places here, so 2.807. Okay? So that's a way we can solve that exponential equation. And this one's very similar. It has the x in the power. I can't make both of them have a base of 7, so I'm going to change this to a logarithm. Okay? So my base is 7, so that means I have log base 7, jump over the equal sign, so it's of 15, equals the power, which is 9x. Okay, so before I type anything in my calculator, I can see to get x by itself, I need to divide by 9. So these 9s make 1, so I just have x on this side. I can type all of this in my calculator. Again, if you're doing change of base, do it first, push enter, then divide by 9. If you're using your calculator, and I just jump down, I'm going to change my base of my log to 7, 15. If I get out of that, I can then divide. I like to just make sure it's going to clear, so I go ahead and push enter. That's my numerator, and I want to take that number divided by 9. Okay? So again, we're going to round and say x is approximately 0.155. We have to round that 4 up, because a 6 comes after it. Alright, let's try it on number 4. Okay, well, I have x in the power. I'm not going to have 2 bases of e, so I am going to change this to a log, but I can't do that yet. I need to get what is taken to the power of x by itself before I change it to a log. Okay? So I need to move the minus 7, and I need to move the 4. So we're going to do order of operations. We're going to subtract the 7 first. So we add the 7. It's a minus 7, so I have to do the opposite, and I add the 7. So I get 4e to the negative 0.3x will equal 20. Okay, I still need e to the negative 0.3x by itself, so we have to get rid of this 4. It's multiplying, so I'm going to divide. That is that inverse operation there. So on the left side of my equation, I'm left with e to the negative 0.3x, and it now equals 5. So I have a base to a power on one side equals a number, okay? And we need to get that x out of the power, and to do that, we're going to write it as a log. So it's log base e, which is the same thing as saying natural log. Okay, log base e. Jump over to the other side of 5 equals negative 0.3x. Okay? And then we need to get x by itself, so I'm going to do that again by dividing by a negative 0.3. So these ones make 1, and I'm left with x. So I can type this in my calculator. Natural log of 5, I'm going to go ahead and push enter, and then divide by a negative 0.3. Oops, let's move it over here. Okay? And again, I have to round, so I get negative 5.365. Okay, I want you to go to your practice and do problems number 5, 8, 10, and 15, and then move on to video number 2.